We are now going to talk about sequences algebraically and recursively defined. So occasionally in the real world, we will need functions that are discrete, that take the natural numbers like 1, 2, 3, and so on. In other words, the numbers that you can count on your hand. For example, we might want to look at the height of a bouncing ball as a function of the number of bounces. So the height at bounce 1, at bounce 2, at bounce 3, and so on. And for this, we'll use what's called a sequence. So a sequence is an infinite list of numbers, often written as a sub 1, a sub 2, a sub 3, ... etc. and so forth. So when you see these dots, those dots mean these dots go to infinity. Go to infinity. And all that this is saying is that we have an infinite number of terms in this sequence. We could go from a sub 1, a sub 2, a sub 3, a sub 182, etc. When you see these numbers, these subscripts these numbers in the subscript 1, 2, and 3, these just tell you the term number. A way you can think about this would be if we have a function called a that accepts the natural numbers 1, 2, 3, 4, etc. A of 1 would equal A1. A of 2 would equal A2, and so on and so forth. So to kind of make this a little bit more concrete, let's consider the sequence A1 equal to 5, A2 equal to 10, A3 equal to 15, A4 equal to 20, etc., and so forth. So looking at this, you've probably already got a pretty good sense of what this is. So let's just think about what's happening for a moment. And we can describe this pattern algebraically as a sub n equals 5n. And if you're thinking that this feels like a linear equation, maybe like y equals 5x, then you're right. You know, we look at our numbers, and this looks like a linear equation, just we're only getting the numbers where we're giving the function a natural number. The main difference between these two is that y equals 5x is defined for x such that x is an element of the reals, whereas a sub n equals 5n is defined for all n such that n is in the natural numbers. Again, the natural numbers are just the numbers that we can kind of count on our hands. I'll draw that a little bit better. The natural numbers. Okay, so another way of describing this is like this. You get from one number, say a sub 1 equals 5, by adding 5 to it to get to the next. We get from one number to the next by adding 5. This is called a recursive definition of a sequence. So I might write recursively. Recursively, we say a sub n equals a sub n minus 1 plus 5. So the kind of using language to describe this would be to say that to get from one term to the next, we add 5. But to go anywhere, we need to know where we started. So we also have to define a sub 1 equals 5. And just to show you that we get the same numbers as in our original sequence, let's write these out. So a sub n equals 5n, and a sub n equals a n minus 1 plus 5, starting at 5. So we have our algebraically defined sequence, and we have our recursively defined sequence. Now, for our algebraically defined sequence, let's say a sub 1, so we're plugging in n equals 1. We get 5 times 1 equals 5. Good. A sub 2, 5 times 2 equals 10. A sub 3, 5 times 3 equals 15. And we'll do one more. A sub 4 equals 5 times 4 equals 20. Okay, good. So our algebraic definition of a sequence works. Let's look at our recursively defined sequence now. We already know that a sub 1 equals 5. A sub 1 equals 5. A sub 2, I'm going to write it out very clearly. So we have a sub 2 minus 1 plus 5. And since a sub 2 minus 1 is the same as a sub 1, we write 5 plus 5 equals 10. Similarly, a sub 3, now we'll grab what we had in a sub 2 here and bring it down right there. So this is a sub 2 plus 5 equals 10 plus 5. And lastly, a sub 4, for a sub 4 we grab a sub 3 and pull it down. And we have a sub 3 plus 5 equals 15 plus 5 equals 20. So this is an algebraically defined and recursively defined sequence. Altogether, the definition of a sequence. A sequence is a function A whose domain is the set of natural numbers n. The terms are a sub 1, a sub 2, a sub 3, all the way up through a sub n, where a sub 1 is the first term, a2 is the second, and a sub n is the nth term.